So good morning to all of you. So in the last class we have discussed different characteristics of PV cell. So today's class we will discuss maximizing of solar PV output, maximizing of solar PV output and load matching maximizing the solar PV output and load matching that we are going to discuss in this particular class. Okay, so already you know that how we will maximize the output power of a PV cell by providing tracking. All the PV panels are continuously tracking with respect to sun. Already know that when a solar ray strikes the PV panel exactly at right angles, the PV panel can able to extract maximum amount of power. Already we know that. Okay, so in order to continuously throughout sunshine hours, okay, so if you want to get a maximum amount of power, if you want to generate maximum amount of power with the PV cell, what we have to do? Continuously the panel has to move according to the sun. Continuously the panel has to move in such a way that continuously ray strikes it exactly at right angles, such that it can able to produce a maximum amount of power all the time. Okay, so for that you have a single axis tracking, two axis tracking. Okay, so we can conclude that by providing tracking to the sun, okay, continuously solar ray strikes the panel at right angles such that it can able to produce the maximum amount of power that we have already seen. This part, maximizing the solar PV output, that we have already seen by providing tracking. Whereas coming to load matching. Okay, so in the solar PV power generation, okay, so not only generation of maximum power, we are generating maximum power by providing tracking. Okay, so that is not sufficient. Okay. So effective utilization of solar power depends upon not only generation of maximum solar power but also, okay, so load matching is also very important. Load matching is also very important in the case of PV cells. Load matching also very important. So coming to load matching takes place through electrical tracking. Okay, so load matching, what we are saying, load has to be matched in such a way that we are generating maximum power. That maximum power should be available to the load. That is very important. For example, let us say already we have drawn the curves. What is mean by load matching? Let us see. Very important concept. So we have seen the generation maximizing the solar PV output, that will be maximized using the tracking. Okay, that is the answer for that particular question. Whereas coming to load matching, what is load matching? Why it is required? That I will show you now. These are the IV characteristics of a PV cell. Let us say this is current and this will be the voltage. From this we will draw the characteristics of a PV. Now I am drawing the characteristics, PV characteristics. This will be called as maximum power point. So let us say I am also representing load characteristics also, the IV characteristics of load also in the same figure. I am going to draw the IV characteristics of load also in the same figure. Let us say the characteristics will be like this. These are the IV characteristics of load. So these are the IV characteristics of PV cell and IV characteristics of the load I am representing in the same figure, such that so the intersection point of load characteristics and source characteristics you can call as a operating point. The intersection, this is the intersection point of load characteristics and as well as source characteristics, which you can call as operating point. Operating point. So if the operating point is at this particular point, if you project into the PV curve, exactly, so even this much of huge amount of maximum amount of power is available, since the operating point is at this particular point, and this much power only can the load can able to utilize. This much power only load can able to utilize. So this much maximum amount of power is available because the operating point is here. If you project, so you are getting this power point. Such that even this much of power is available. The load can able to utilize only this small amount of power. Because the operating point is here. So by changing some electrical characteristics of a load, if you can able to move this operating point to at this particular point, so already know that by changing the electrical characteristics of a load, it may be voltage, it may be current, it may be resistance, by changing some electrical characteristics of a load, if you can able to move this operating point to this maximum power point, maximum power will be available to the load. This is called as load matching. Moving the operating point to the maximum power point can be called as a load matching by changing some of the electrical characteristics of the load. You can have a best example here. Here you have a, so Q1, Q2, Q3, R1, R2, R3. Let us say a PV cell I have considered. Already know the PV cell can be represented with simple current source which generates a current of IPH. A diode will be parallelly connected. Let us say which I am representing with D. Already we have represented the diode current will be ID. Now across this PV cell, let us say I have connected a load. Let us say with a resistance of R1. It is a variable resistance. Let us say I have fixed the resistance at R1. So by keeping one voltmeter here, and ammeter here, for different voltages, what are the different currents, I have calculated the same voltage and current. So I would like to calculate what is the voltage across the resistance. What is the voltage across the resistance? What is the current across the resistance? So I would like to calculate, and the same thing I will represent here. So I would like to calculate the current flows through the load and voltage across the load. With that I will draw the characteristics. Let us say for resistance R1, these are the characteristics. These are the characteristics of PV cell, and these are the characteristics of load. Same, the operating point will be here. For resistance R1, if you vary voltage and if you get a different currents, the VI characteristics, if you project in the same graph, the operating point will be Q1. Now I am changing one of the characteristics of the load, resistance R1 here. I am changing resistance R1 to R2, such that operating point changes from Q1 to Q2. Such that operating point will change. I have again drawn the graph, and so now the operating point will be this one. The maximum power point will be the operating point. Now if I keep on increasing the resistance from Q2 to Q3, this will be the operating point. Here my conclusion point will be, by changing the electrical characteristics of a given load, it is a voltage or current or frequency or you can say resistance, or impedance. By changing electrical characteristics of a load, you can change the operating point. You can change the operating point from Q1 to Q2 and Q2 to Q3. You can able to change. Okay. So always the operating point has to be moved to the maximum power point, such that always load will have a choice of utilizing the maximum power. Load will have a choice of utilizing the maximum power. Already we have seen that. Okay. If it is a okay, again, I would write a graph here. Let us say. I will explain clearly. You can see. You can observe here. Let us say the same graph I am drawing. These are the IV characteristics of PV cell. Corresponding PV characteristics also I am drawing. Starting it is 0. At the ending, again it will be 0 here. Now what I would like to do is, okay, so I would like to draw this is the maximum power point approximately. I would like to draw it. Maximum power point, I have drawn. This is the maximum power. So if the resistance is at R1, the curve will be like this. If the resistance is R1, the curve will be like this. The intersection point, what I am saying, this is the operating point, that is Q1. The intersection point I am calling as a operating point, that is Q1. Okay, operating point is Q1. And the operating point is Q1. You can see for this particular load R1, the power available only this much. Okay, whereas this much huge amount of power is available, but load can able to utilize this much only. So load unable to, because the operating point is deviated from the maximum power point. Okay, the load can able to utilize only a small amount of power only. Even it is available, we are generating maximum power, but the load cannot able to utilize it, because it is operating at this particular point Q1. It is not operating at maximum power point. It is operating at some other point, so that it cannot able to utilize the maximum amount of power. Now what I am doing? Okay, I have changed the resistance to R2 such that VA characteristics will be changed. If you project the characteristics, you will have at R2 the VA characteristics of a load will be like that. If you superimpose in the same, okay, this is going through the maximum power point. Then, okay, if the load is at R2, the curve, okay, the operating point as well as the maximum power point will be the same, such that it, okay. So if you observe here, project here. So at R2, the load can able to, okay, utilize maximum amount of power. Okay, so because it is intersecting at this particular point. Okay, so maximum power what we have generated will be available for, okay, particular load at a value of R2. Again, I am increasing the resistance. Okay, you can observe here. This is operating point Q2. Operating point and maximum power point will be the same. Now, okay, again I am drawing. I am increasing the resistance R3, such that what is happening? You can be able to observe. Okay, very small amount of power is available. Very small amount of power will be available now. Okay, so operating point deviated from the maximum power point, and the available power to the load at a value of R3 will be very less. Okay, less than before also. This means I would like to conclude that. Okay, okay, you can change the operating point. Okay, if the operating point is at maximum power point, load can able to utilize the maximum power. Okay, because okay, we are generating maximum amount of power. Total maximum amount of power can be utilized by the load. if the operating point is at the maximum power point. If the operating point is at the maximum power point. Whereas, okay, if it is deviated from the maximum power point, what will happen? Okay, even we are generating maximum power, but load cannot able to utilize that. Okay, maximum amount of the power. Okay, such that in a PV cells, load matching is very important topic. Very important topic. Load matching is attained by changing the sum of the electrical characteristics of the load. Operating point is slowly moving to the maximum power point, such that always load can able to utilize maximum amount of the power. Thank you very much.